Okay, Algebra 2, this is 4.8 quadratic inequalities. So we're going to do two things. We're going to solve them graphically, see what they look like graphically, and then at the very end we will do it algebraically as well. So the first thing I need to talk about when we have inequalities is that what are these symbols and what do they mean? So the first one is greater than. The next one is greater than or equal to. The next one after that is less than. And the last one is less than or equal to. Now there's something else that we have to talk about when we do these, so I'm going to move these over just like so. And what we have is we have to talk about when we go to graph, what do they look like? So the first one on the greater than and the less than one, they are open dots on graphs. Because if I say I have to be greater than 5 feet to ride a ride, I cannot be 5 feet. I actually have to be 5 feet something to be able to go on the ride. Now if it says you have to be at least 5 feet, then I could be included. So therefore if it's included, it ends up being a solid dot. So the ones that say equal to are anytime we have a number line or using graphs, it will be a solid dot. Now number lines usually where we use the open and closed dots. On a graph, when we're talking about x and y, we will be talking about more of a line or a curve. And so if the curve is not included, it is a dashed line. And if it is included, it's a solid line. So all the ones that we were doing before, like y equals 2x plus 3, those are equal to, so that's why they are solid lines. Every point along the line was the solution. It was the only solutions, right? Were the ones on that line. Now that we're talking about inequalities, we're going to talk about shading a particular region, inside or out or up or below. So therefore the line might be or might not be included. That's important. So there are different forms here. I tried to split it up, and I'm trying to give you some steps on how to graph each one of these, or some of those things that we have talked about or should have talked about prior to this lesson. You got standard form, which is y equals mx, it's on mx plus b, ax squared plus bx plus c. And if you have this form, you know that the y-intercept is the c value, because if you put in x, you get c out. We also find the line of symmetry, the thing that cuts it in half at opposite b over 2a, and that leads us to a vertex. We did this one pretty heavily, and then we put that vertex and things in the middle of a t-chart or a table so that you can find the values on both sides, and therefore you got your critical points. Then you're going to go back and ask yourself, is this solid or dotted? And then we're going to continue to move from there on the next slide when I give you the information. This is just for graphing. If it's in vertex form is a times the quantity x minus h squared plus k, where here's the cool thing, h and k are the vertex. And so therefore you put that in the middle of a table or a t-chart, find values that are equal distance away, and therefore you can graph it very easily. And then we have intercept form. They say p's and q's, where p and q are your x-intercepts. So here's the cool thing. If you know that you have x-intercepts here and here, well, guess what? The middle, which somewhere is about here, is where the line of symmetry will be. So what you can do is that you can find the vertex in the middle. So you find the x value down the middle, which would be somewhere about here, and then you can plug that x value back into the equation stated above, and therefore you can find your y value to the vertex. You plug it into a t-chart. It's as easy as that. And sometimes even just those 3 points, because if you find your vertex is up here, then you can make a nice curve like that. So 3 points might be enough. So those are the 3 types of forms that we're of quadratics that we'll have to deal with. But a lot of times we're going to deal with the standard form. Now, there are 3 steps that I have for graphing inequalities, and this can actually hold true for not just quadratics. So I want you to graph the function. When I mean graph the function, is more than likely get through all of the steps that you would normally do to graph it, but stop right before you actually do the graphing. So that means maybe finding x-intercepts, y-intercepts, making a table, finding a vertex, finding the slope, finding all of those things that may be part of different graphs. Then you look at that inequality symbol. Does it say equal to? Then make sure it's solid. If it doesn't, then leave it and make it dotted. It's not included. So then you swoop in your curve with a solid or dotted. And the very last thing we're going to do is we're going to check a point either above or below, to the right, to the left. And if it works, we will shade that side. If it doesn't work, we have to shade the other side. Because if it's not heads, then it has to be tails. So if it doesn't work on one side, it will work on the other. So make sure you can take that in consideration to make your life a little bit easier. You don't have to prove it works to shade. So here's our first problem, our only problem that we are going to actually do the shading of. The other one will be done algebraically. So this is in standard form. So I am going to first say, hey, I have a y-intercept at 0, 2. Because if I put a 0 in, I'll get 2 out. That was nice. I'm going to find my line of symmetry, which is x equals opposite of b over 2a. And so if I start to plug those in, I get opposite of negative 6 over 2 times 1, which is 6 over 2, which is at 3. So x equals 3 will be the line that splits my graph. But that means I know that my vertex is at 3 comma something. So I'm going to put 3 in. 3 squared is 9, okay. But 6 times 3 is negative 18 because it's a negative 6. So 9 minus 18 is negative 9 plus 2. So negative 7. So I get 3 negative 7. And I'm going to take that information and I'm going to make a t-chart. 3 negative 7. I'm going to put 2. Ooh, I'm going to skip 1. So I'm going to put 2 and 4 because 2 is 1 up, down and 4 is 1 up. But from 3, I can step back 3 to get to 0. But if I step 3 up, I have to be at 6. Because I know what happens when I put 0 in. I'll get a 2 out, which means I'll get 2 at 6. I'm using the knowledge of how things work and how they're symmetrical. If I take 4 steps up, I have to take 4 steps down. They'll be the same values. So now you have to ask yourself, what's easier, putting a 2 in or putting a 4 in? I think the smaller number is generally a little bit easier. 2 squared is 4. 2 times negative 6 is negative 12. So 4 minus 12 is negative 8 plus 2 is negative 6. Okay? So now I have to decide, is this a solid or dotted graph? Well, if I'm looking at my inequality, it does not say equal to. So therefore, I have to be dotted. So it's dotted. So when I go to graph these, now notice I have a lot of negative numbers in the y. So 1, 2, 3, 4, 5, 6, 7. I think is the most it goes. 1, 2, 3, 4, 5, 6. 0, 2, 2, negative 6. Somewhere about here. But then I can go to 3, negative 7. And then go up to 4, negative 6, and at 6 I'll get 2 again. So there are my dots. I have to connect them, but remember, like we said, it's going to be a dotted curve. Okay, so there's my quadratic. It doesn't look overly pretty, but it will work. Now, I need to check a point. I'm going to check a point so I can shade. Now there's one point in particular that I would love to use, and I can use this point as long as it does not run onto my curve does not run through it. And so that point is this one right here, that red dot, and that red dot is at 0, 0. I like to use 0, 0 because it makes all x's and y's equal to 0. So I'm going to go up to my original problem, and I have to plug in x is 0. So if I plug in 0, and if it works, I'm going to shade that side. I'm going to shade everything on the outside. If it doesn't, then I have to shade on the inside. So 0 squared minus 6 times 0 plus 2 has to be greater than 0. Well, guess what? This is all 0. So is 2 greater than 0? Is that true? Yes! So therefore, I'm going to shade everything that would make it true, and that's everything on the bottom or outside of the curve. And that's because there are an infinite amount of solutions. Not just one solution. Every point out here. So like -5, -2 is a solution because it's in the red shaded area. So what I want to do is I want to solve this algebraically. To do that, what we're going to do is use those techniques that we had from before, and we're going to find our x-intercepts. So we're going to set this equal to 0 by adding 6. So I get x squared plus 5x plus 6 is less than 0. Okay. And then I want you to factor. Now if you go back to what we did before, you would say, hey, a is equal to 1. So that's really nice. I just find the factors of 6, 1 and 6, 2 and 3. That'll give me a 5 by adding, because both of these are adding. So we know this is both adding. So if I try using 1 and 6, I would have to add them, and that would give me a 7. Not going to work. So 2 and 3 are our critical points, or our factors. Now, what you want it to do is you almost have to act like this is an equal sign so you can find the actual values of x. So I'm going to set x plus 2 equal to 0 and x plus 3 equal to 0. Because my goal here, guys, we're not trying to graph this. Because if I try to graph this, then I would find out that the graph will have x-intercepts at -2 and -3. So when I go to graph it, you will have a cross here and cross here. And the graph does open up. So the graph would look like this. The vertex is in the middle somewhere. Okay? It's not asking us for that. So instead of shading all out here or all in here, I just want to shade on a number line. So it's either going to be shaded on the outsides or it's going to be shaded right in the middle. And so to do that, what we're going to do is we're going to find that we have 3 distinct zones. These values of -2 and -3 is splitting our x's. Now I'm going to draw some dotted lines that do not exist, okay? It's almost like our graph has 3 zones. I got zone 1, I got zone 2, and zone 3. Your job is to figure out which one of those zones works. Now here's the cool thing. It's either you're going to shade in the middle or you're going to shade on the outsides. And what I mean by that is either you're going to heavily shade the middle so that all solutions between -2 and -3 work, or you're going to shade on the outsides and say it's from -2 backwards down, or -3 backwards, or it's going to be -2 greater than. Now, I realize that I actually made a mistake here with these points. These points are actually, and I'm going to change back to red, are actually open dots. And why are they open? Because the original inequality is less than. They should not be included. So either I'm going to shade in between here, or I'm going to shade to the 2 outsides. To do that, it's really cool. All I need to do is, again, check a point and see if it makes it true here. So I am going to switch to another color, and I'm still going to use 0, 0. I'm still going to use 0. And is 0 squared plus 5 times 0 plus 6 less than 0? So this is all gone. Is 6 less than 0? And the answer is no. So guess what? All of this side, from -2 greater than -2, will not work. But also -3 downward will not work. So the answer actually lies between the 2 points. So now what we have to do is you have to actually name it. It is -3 is less than x, which is less than -2. That is your solution. Now, if it said that it should have shaded outwardly, so maybe it was supposed to be green, then you could say that x is less than -3, or x is greater than -2. So that would be the green if we were shading outwardly. But right now we're shading inward, so therefore we use this one. So your homework is these 5 problems. So remember the first 3, make sure you show your graph. And the last 2, 9 and 10, all you have to do is show the actual inequalities that would make it work. So check points in all of those. Have a great day.